The last section, 6.5, solving radical equations algebraically. So let's do it. Not my fault. 6.5, language, solving radical equations algebraically. We did this section, well, kind of like the section where we solved these graphically. Remember, we put each expression in y1 and the other one in y2, and then we found the point of intersection. Well, now we're going to do it algebraically. Okay, you ready? How do I get rid of radical? That's right, raise it to the power 2. Okay, so the power 2 cancels out the radical. I get x. And 5 squared is 25. Now, when we do this algebraically, we end up with extraneous solution. So you have to check your answers. So I go back to the original equation. I know x is 25, so I'm going to plug it in. Does the square root of 25 equal 5? Well, it indeed does, so I know that this checks. Number 2. I have negative 2 plus the square root of v equals 8. So I have to get the square root of v by itself. I'm going to add 2 to both sides. I get the square root of v equals 8 plus 2 is 10. Now I have to get rid of my radical, so I'm going to raise it to the power of 2. Radical cancels out 2. And I get v equals 10 squared is 100. I have to check my answer. Make sure it's not an extraneous solution. So I go back to my original equation. Negative 2 plus the square root v is 100. Does that equal 8? Well, negative 2 plus the square root of 100 is 10. Does that equal 8? And sure enough, it does. So I know this checks. Okay, number 3. I have to get rid of the radical. So I'm going to raise it to the power of 2, both sides. I get 3n plus 4 equals 16. Solve for n. I'm going to subtract 4 from each side. And I get 3n equals 12. Divide by 3. Divide by 3. I get n equals 4. Need to check it. Go back to my original. Square root of 3, my n is 4. So 3 times 4 plus 4. Does that equal 4? So the square root of 12 plus 4 is the square root of 16. It indeed checks out. Yes, ma'am. Okay, number 4. Does everybody know that the power 1/2 is radical, is the square root? Back when we did exponent form to radical form, do you remember? Exponent form, radical form. Okay, exponent form was I had the base raised to the exponent divided by the root, and that became the root to the base. Thank God, because you guys didn't do too well on the quiz. And the exponent was up here. Radical form to exponent form and vice versa. Okay, so I'm going to change this 1/2, which is exponent form, to root form. So I have 5 equals the square root of 9m minus 2. Because the root 2 and my exponent's 1. Okay. I'm going to square both sides. 25, I'll talk about all that later. 2 cancels out the square root. I get 9m minus 2. I'm going to add 2 to both sides. I get 27 equals 9m. Divide by 9. Divide by 9. So 3 equals m. I have to check it. Check it for extraneous solutions. So I have 5. Does that equal the square root of 9 times 3 minus 2? Does 5 equal 20 square root of 27 minus 2? And it sure indeed does. It checks out. Questions, comments, concerns? Not yet? Cool. Wonderful. How's yours? Good. All right, number 5. I have to get rid of radicals, so I'm going to raise it to the power of 2. Okay, the 2, power 2 cancels out the radical. So I get 3, or I'm sorry, negative 3 minus 2x equals 2 minus x. Got to get my x's on one side, my constants on the other. So I'm going to add 2x to both sides. I get negative 3 equals 2 plus x. Then I'm going to subtract 2 from both sides. Yep, x equals negative 5. I have to check it. Check, check, check. Yes, you have to check. Yes, you will get problem marked wrong if it's not checked. It's so stupid. All right, square root of negative 3 minus 2, my x is negative 5. Does that equal the square root of 2 minus negative 5? Let's see, square root of negative 2 times 5 is positive 10. Does that equal the square root of 7? And yes, it does. Now we get into some funner stuff. Funner. Number 6. What do I do? Yeah, raise it to power 2. So negative 30 plus 11b equals b squared, or not to be squared. Question. Now what? The quadratic. What do we do with quadratics? The what? Yeah, well, we get everything on one side and 0 on the other, right? Then we could use one of the 4 methods of solving quadratics that we just spent a month on, right? Right? Let's see, we had solve by factoring, we had solve by square rooting, solve by completing the square, and solve by quadratic formula, right? 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 Okay, so I'm going to I'm gonna get my quadratic over on this side because I want my b squared to remain positive. Why? Hey, shut up. So I'm gonna add 30. Add 30. I'm gonna subtract 11b. Subtract 11b. I don't care. Then you would have to deal with a negative sign in front of the square term. So I get 0 on this side. See how I get a positive b squared? Minus 11b plus 30. Which one do you want to use? Complete by square rooting, complete by completing square, I'm sorry, factor. Factor by completing square, factor by factoring, or factoring by using the quadratic formula. That's right, I'm going to use by factoring because I can, it's easy, I'm super good at it. B times B is B squared. I have a positive 30, positive, it has to end up being adding to a negative, so they're negative. 2 factors of 30 that end up to add up to 11. That's right, boys and girls, 6 and 5. So what does B equal? 6 and 5, right? That's what we get to do. Check both of them. Isn't that fun? Told you it was funner. So I'm going to check. Let's check the 6. So I have the square root of negative 30 plus 11 times 6. Does that equal 6? Let's see. Square root of negative 30 plus 11 times 6 is 66. Does that equal 6? Let's see. I have the square root of 36. Wow, indeed it does. That checks. So let's check 5. Does the square root of negative 30 plus 11 times 5, does that equal 5? See, I get the square root of negative 3 plus 50. I'm sorry, that should be 30. Negative 30 plus 55, does that equal 5? Negative 30 plus 55 is 25. Square root of 5 is 5. Wonderful, that works. So these check out. No extraneous solutions. Oh, did you leave it back? Okay, any questions thus far? Any questions thus far? Okay, you guys are going to have to get quizzed on this, so please pay attention. Number 7. Ooh, this one's even funner. Okay, what do I do here? I have to raise it to the power of 2, right? This is funner and longer because it's harder. So I have v minus 2 times v minus 2 equals, this cancels out that. I think it is 5 and 3. 4v minus 11. Now what do I do? I have a binomial times a binomial. What do I do? Foil it. This is where the fun kicks in. V times v is v squared. Outer. V times negative 2 is negative 2v inner. Negative 2v, negative 2v plus negative 2v is negative 4v. Last, negative 2 times negative 2 is a positive 4. Now what? Quadratic. What do I do? Get. Huh? Yeah, get everything on one side, 0 on the other. Subtract 4v. Subtract 4v. Add 11. Add 11. That gets me 0 on this side. I get my v squared Negative 4v minus 4v is minus 8v. I am adding negative 4v. And 4 plus 11, 15. Again, which method do you want me to use? Factoring, Mr. D. Good call. Okay. V times V. Yes. Let's say this is a plus, that's a minus, so it has to be a minus minus. Two factors of 15 that add up to 8, 3, and 5. So what does V equal? 3 and V. All right, guess what we get to do? We have to check both of these. Okay, let's check the 3. Let's see, 3 minus 2 equals the square root. 8, what's your language? 4 times 3 minus 11. 3 minus 2 is 1. 4 times 3 is 12. 12 minus 11 is 1. Square root, yes, it does. So 3 checks. How do you know? There's actually an easy way. I'll show that after the next problem. Okay, I have to check 5. 5 minus 2, does that equal the square root of 4 times v, which is 5, minus 11. This is 3. This equals 20 minus 11. And that's going to be 9. Yeah, hey, checks out. Guess what? They both check out there, Logan. And the last new problem I'm doing for this year. Yay. All right, number 8. I have to get the radical by itself first. So I'm going to add n to both sides. So I get the square root of 15 minus 2n equals n minus 6. Oh boy, guess what I get to do again? Well, okay, I have 15 minus 2n equals n minus 6 times n minus 6. What? My last problem, remember. All right, FOIL that. 15 minus 2n equals n squared. Let's see, I've got n times minus 6 is minus 6n, the inner minus 6n, so I have a minus 12n. All right, negative 6 times negative 6, positive 36. I need a 0 on one side because I have a quadratic now. Okay, I'm going to subtract 15, subtract 15. I'm going to add 2n, add 2n. I get a 0. N squared minus 10n plus 21. Okay, which of the 4 methods have we learned in the past semester here? Do you want me to use to figure out the root for the zeros? Factoring, Mr. D. Okay. All right, so I'm going to factor n times n. That's a plus, minus, so they both have to be minus. How about 7 and 3? So what does n equal? 3, 7. That's what we get to do now. Check. Isn't that fun? Okay, check. Let's do the 3. Does negative 3 plus the square root of 15 minus 2 times 3 equal negative 6? Okay, negative 3 square root of 15 minus 6 is what? square root of 9? Does that equal 6, negative 6? So, does negative 3 plus 3 equal negative 6? No, it does not. 3 is an extraneous solution, so Logan would have got that one wrong. Because he doesn't check. Okay, we have to check 7. Does negative 7 plus the square root of 15 minus 2 times 7, does that equal negative 6? Nathan, shut up. Okay, negative 7 plus the square root of 15 minus 14, does that equal negative 6? We have negative 7 plus the square root of 1, which is 1. Does that equal negative 6? And the square root is 1. Negative 7 plus 1 is indeed negative 6. Oh, n equals 7. Questions, comments, concerns? Okay, I told Logan there's an easier answer how to check these. Okay, first of all, when we have situations where we go ahead and solve these and we do not have a quadratic, like numbers 1, 2, 3, 4, 5, okay, no quadratics, right? They're linear. You do not have to check. You do not have to check linear. When you get into problems like 6, 7, and 8, where you get a squared term, then you have to check for extraneous solutions. So that should cut your work probably by half. Just check quadratic equations for extraneous solutions. Now, there's an even easier way on these particular problems that you could check to see if there were extraneous solutions. Well, how's that, Mr. D? How much easier can it get? It's so easy to begin with. Well, I'll tell you. Look at that. How about that? That's pretty easy. Are there any questions on the last section of the year? Oh, let's talk about finals.